Okay, we've just learned how to find the expected return on this portfolio of two stocks consisting of half of our money in the high-tech stock and half of our money in the collection stock. But of course, expected return is only part of the picture. We also want to talk about the risk of the security, and we measure that by standard deviation. So the next thing I'm going to show you is how to do the standard deviation for this portfolio. Now, as you recall, for an individual stock, you can't really do standard deviation until you first calculate the expected return, because standard deviation tells us something about how far off of the expected return that these individual outcomes are likely to be. And of course, we just calculated expected return as 6.7%, so now we know what that is, and we can go on and proceed to do the standard deviation. So here's what we have. Remember that in each case for the standard deviation, we're going to look at the outcome. So we've got the 0% outcome for the recession case, 3% for below average, 7.5% for the average case, 9.5% for above average, and then 12% for the boom case. And in each case, we're going to subtract off the expected return on the portfolio, which of course is just 6.7%. So far what we're doing, like I've said, is we're taking each possible realized outcome and we're subtracting off the average or the expected outcome of 6.7%. Then in each case we're going to square the difference. So it doesn't really matter whether it's a negative difference or a positive difference, because when we square it, it's going to end up being a positive number anyway. And then finally, when that is done, that is, we've squared these differences, meaning we multiply each one by itself, then from these 5 results separately, we're going to multiply by the probability of each of the respective cases actually happening. And the reason we do that is because, remember that more likely outcomes should carry a greater weight in the overall process than less likely outcomes should. So once you've done that for all 5 cases, and then you add up all 5 results, you've got what we call the variance of the portfolio, and variance is sigma squared, and so you've got to take the square root of that. And in this case, what we see is we are raising it to the 1/2 power, which is the same thing as taking the square root, and the end result is 3.4%. Now, that's the standard deviation of that portfolio. And of course, if you wanted to get the coefficient of variation, hopefully you remember that from the first part of the chapter as well. Coefficient of variation is just the standard deviation, which would go into the formula here, and then you would divide that by the expected return of 6.7% to get 0.51, and coefficient of variation is not a percentage, so this is not 0.51%, it's just 0.51. Alright, now in the process of doing all of those calculations, sometimes it's easy to lose sight of the significance of the result we just found. The standard deviation of that portfolio is 3.4%. Now, when you step back and think about it for a minute, that's actually pretty amazing. And the reason is because, if you remember, the high-tech stock had a standard deviation of 20%, and the collection stock had a standard deviation of 13.2%. So, how is it then that you can combine two things in a portfolio? One of them has a 20% standard deviation, one of them has a 13.2% standard deviation, and yet the mixture of the two has only a 3.4% standard deviation. That's lower than either one of its components. That's pretty amazing. Well, I'm going to talk about the reason for that here in just a second. But first, let me say I can't guarantee that this dramatic of an outcome is always going to happen. It isn't always going to be true that the standard deviation of the portfolio is going to be less than either one of its components. Sometimes that happens, but not necessarily in every case. However, I can guarantee you that it will never be more than the weighted average of its two components. Remember when I said that when I was taking my first finance class that I kind of thought that maybe the standard deviation would just be found by, in this case, taking 0.5 times this one and then 0.5 times this one? Well, that weighted average would be 16.6%. And in this case, we clearly see that the standard deviation of the portfolio is far less than 16.6%. And one thing I can tell you with certainty is that it will never be more than that weighted average. And in fact, it will almost always be less. There is only one really special case where it would even be equal to that amount. And in almost every real world case, it would be less than the weighted average of the two standard deviations. So the end result here is that mixing these two things together in a portfolio provides an expected return that is the weighted average of the individual stock's expected returns. So we got the weighted average of the expected returns of the individual components of the portfolio, but we got less than the weighted average of the risk measures. So we didn't really sacrifice expected return by doing this, but we did reduce our risk. Now that is a good deal. Any serious investor is going to be very happy if they can keep their expected return at about the same level and yet manage to reduce their risk. That's a very good deal. Now, why did this work so well in this case? I mean, this did work exceptionally well. Down to 3.4%, I mean, that's a minuscule amount of risk. The reason in this case is that we had negative correlation between these two stocks. What does that mean? Well, correlation refers to the tendency of two things, or two random variables, to move up and down together. All right? And most of the time stocks are positively correlated, which means that usually when one of them has a above average day, that is, it does better than expected that day, then the other one tends to also do better than expected that same day. And when likewise one of them does worse than expected on any given day, then the other one usually also does worse than expected. But in this case, we've got negative correlation, and that's kind of unusual. Negative correlation would mean that when one stock has an above average day or week or month or year, then the other one tends to have a below average day, week, month, or year, or whatever the time period would be. And likewise, when the first one has a below average investment period, then the other one is at least more likely to have an above average investment period. That is, these two stocks tend to go in opposite directions. And actually, if you just look back at the probability distribution that we saw earlier, and you just look at the columns here for the high-tech stock and for the collection stock, you'll see that's definitely true. One does better when the other one does worse, and vice versa. The high-tech stock does well when the economy does well, but the collections company stock does well when the economy does badly. So these two things move in opposite directions from each other, And that's why we say that they are negatively correlated. And if you can find two investments like this that are actually negatively correlated, then those are great to combine in portfolios for purposes of risk reduction. Those are the most those are the most effective stocks as far as combining them together and reducing risk. So let's talk about the risk of stocks in general and how they tend to behave. First of all, the standard deviation for an average stock is probably about 35%. So if you just took a stock at random off the pages of the Wall Street Journal, and let's say that we all did this, the entire class took each one of us randomly selected a stock off the page of the Wall Street Journal, and we found its standard deviation, and then we compared notes. Chances are, on average, our answers would hit about 35%. Some of us would have randomly found a higher risk stock, some would be lower, but the average amount, again, 35%. Now, as far as correlation, remember I said that most stocks are positively correlated with each other and with the market in general. That is, when the market when the market does well, that is, it has a better than expected day or week or month or even year, then it's also likely that any randomly chosen stock will also have done better than expected. So stocks tend to have good years and bad years at the same time. Okay, there's positive correlation. They tend to sort of move up and down together. And mathematically what that says is that their correlation coefficient, that is rho, I know this might look like a lowercase p, but it's not. It's a lowercase Greek letter rho. The value is going to be between 0 and 1. All right, now just a little word about correlation coefficients. They are always somewhere between -1 and +1. You can never have a correlation coefficient less than -1. You can never have it greater than +1. And in the real world, for any given stock, or any two given stocks, I should say, most of the time the correlation is going to be on the positive side. Now, it won't be at the extreme. It won't be perfectly positively correlated. That would be a coefficient of 1. But a coefficient of 0.5, or in the neighborhood of that, give or take a little, would not be unusual at all. Meaning that even though the stocks still have somewhat of their own behavior, they have events that affect that firm individually that doesn't affect other firms. There are still factors that sort of affect all firms at the same time and cause them to be correlated with each other, economy-wide stuff. All right, now when we combine stocks in a portfolio, we find that it generally lowers the risk of the portfolio, and that was certainly true in the example of the high-tech stock and the collection stock that we just did. Now, the amount of risk reduction that we get is going to be dependent on the correlation the correlation coefficient. Okay, and the lower the correlation coefficient is, the better the reduction in risk that we can get. The higher the correlation coefficient, the less of an effect that we'll obtain. Let me show you the two extremes here. Let's look at a case where we've got a correlation coefficient between two stocks of -1. That's as low as it can possibly be. And we call that perfect negative correlation. So this means that when one stock has an above average year, then the other one has a below average year, for example. And furthermore, since it's perfect negative correlation, it actually means that the stocks behave in relation to each other anyway in a perfectly predictable way. In other words, I've got stock W and stock M in this case. And so perfect negative correlation means that if you tell me in any given period what stock W did, then I can tell you for sure what stock M did in the same period. And it will have been basically in the opposite direction. So in the first year, you'll see that stock W was above average, okay, and stock M was below average. Whereas in the second year, stock W was below average, but stock M was above average. And pretty much these things behave as mirror images of each other with respect to their average level of performance. And it turns out that if you combine two investments like this in just the right proportions, that is, you select the right amount of money to put in one versus the other, then guess what will happen with the portfolio? This is actually pretty amazing. With the portfolio, you will get the average expected return with no risk. Look at that. That would be wonderful. If we could pull that off in a real world scenario, that would be absolutely incredible. In both these cases, stock W and stock M have an average return of 15%, but they have risk. But the portfolio of the two has the same expected return, but no risk, and that would be great. Now, before you get too excited about this example and go off trying to find two stocks that have a 15% average return and are perfectly negatively correlated with each other so that you can basically get a risk-free 15% rate of return in your portfolio, let me just tell you, you're going to have an awfully hard time finding that in a real-world case. Most likely, if you found two stocks that were negatively correlated in this manner, then one of them would have a substantially lower expected return than the other. And we're going to talk later on toward the end of this chapter about why that might be and what you might really expect to see. But if you were actually able to construct a risk-free portfolio in this manner, you probably wouldn't get a 15% expected return on it. You would get something more like, well, the risk-free rate of return, because it would be a risk-free investment. So that would be logical. All right, now that's what you could do in the extreme of perfect negative correlation. What about the other extreme of perfect positive correlation? Here is a graph of the performance year by year of two stocks that have perfect positive correlation with each other. Well, in this case, what do you see? These two graphs are pretty much the same thing, right? You've got two stocks that they move in lockstep with one another. I mean, what one of them does, the other one does in a perfectly predictable way. Again, because it's perfect positive correlation, that means that if you tell me what stock M does, then I can tell you for sure what stock M prime also does. And I can also tell you, because it's positive correlation, that they are moving in the same direction. That is, when one of them does better than expected, then guess what? The other one's also going to do better than was expected. Now, when you combine two stocks like this in a portfolio, what do you think the result looks like? Well, in this case, shouldn't be a big surprise. The portfolio of the two looks a whole lot like either one of them individually. Okay? because they both do the same thing. They both earn pretty much the same rate of return in this example. So the portfolio is going to earn that return as well. And notice that there really isn't any reduction in risk going on here. You remember me saying just a few slides ago that I told you about this weighted average of the standard deviations, and I said that the standard deviation of the portfolio over here couldn't ever be more than that number. Well, that's true. It can't ever be more than that number. And there's only one special case where it can even be equal to that number. And that special case is, you probably guessed it, right here. In the case of perfect positive correlation between these two stocks, this is the only time that it does not help as far as reducing risk to make a portfolio out of these two. Any time, though, that you've got anything other than perfect positive correlation, you can combine the two stocks in a portfolio so as to reduce risk. And that's what I'm going to talk about next.